In this video, we're going to start talking about factoring polynomials. And I say we're going to start talking about it because there are a lot of different ways to factor polynomials, and this will be the first video on factoring using a couple of different methods, and then we'll do another video that continues talking about different types of factoring with polynomials. First of all, to talk about what is a factor, what does that mean to be a factor? If you think back to your definition of what you kind of think in your head of are numbers factors of other numbers. Well, that's what we're talking about with polynomials either. Also, we're talking about if a polynomial goes in evenly and it has no remainder, then it is a factor. And so that's what I've written over here in the margin. I recommend you write that down, that a factor goes in evenly. It has no remainder. So if the question asks, is something a factor of something else? Well, you have to ask yourself, does it go in evenly? And if it goes in evenly, then it is a factor. So we have options here on how to do this. We need to divide it. That's what it's basically asking us to do, is it going to divide and have a remainder or not? Our two choices on division are synthetic division or long division. Or if you are a box method person, you could do the box method. I'm going to do synthetic division. I think most people kind of prefer that synthetic division method. Remember, what we do for synthetic division is we take this and we set it equal to 0. And so if this is equal to 0, then we subtract and we get x is -1. And so -1 goes in the corner. We're going to put our coefficients across the top. And our coefficients are 1, -3, and 1. Okay, so now that we've set it up, we bring down our 1. We multiply -1 times 1 is -1. Remember that we are adding these as we go. So -3 and -1 is -4. We multiply -1 times -4, that's a +4, and then we add those and we get 5. Well, it has a remainder. And so the question was, is it a factor? Well, the answer is no. And the reason that the answer is no is because it has a remainder. And so that's what all these questions are going to be asking you. If it says, is it a factor of something, then you just have to do your division and decide yes or no. Take a second right now to pause the video and set this one up, do your long division, and see whether or not it is a factor. Remember to look at the polynomial here and notice that we're missing an x squared term. So don't forget to put that in your synthetic division when you do that. Okay, when you've set this one up, your coefficient across the top are going to be 3, 6, 0, because the x squared term, -5, and -10. We bring down the 3, we multiply, we get -6, we add that and we get a 0. Multiply it, get 0, 0, and 0. Come back here, add them, we get -5. Multiply, we get a +10, and so 0 is our remainder. So the question, is it a factor? The answer is yes, because there's no remainder. All right, let's look at the next section, a slightly different concept on the next section. Here we're going to relate factors to graphs. Do you remember when we did quadratics? If we had it in factored form, what did that give us? Well, that gave us the x-intercepts. And so that's what I wrote over here in the margin, that the solutions of the factors give us the x-intercepts. In other words, if we set x plus 2 equal to 0, and if I set each of these equal to 0, then I get 3 intercepts. And those are going to be my x-intercepts, so I'm going to go ahead and draw in my graph. So I have a -2, a +1, and a +3/2 or 1.5, which is here. So that's why I counted by halves, so I could space it out a little bit better. Now, what's it going to look like? It has 3 intercepts. What does that tell us? Well, the other day we did a project on Desmos, and look, if you multiply this out, what would it come out to be? Hopefully you know that this is going to be a cubic equation. And we know a couple things about cubics. Cubics can look like this, or they can look like this. And, well, which one is this? So if we look at this, if we multiply this out, would the leading coefficient be positive or negative? Well, they're all leading coefficients here are all positive, so it's going to be positive. And the positive means it's going to go up from left to right. So this example that I've drawn over here is a positive. This one, because it goes kind of in the downward direction, that's a negative, and that's not the one we're going to use. We're going to use the positive one. So for this, at this point in what we are doing, I don't really care how high things go. Now, one thing I might care about is what is my x-intercept going to be? And so I might think about this again. Think about it logically. We don't have to multiply it all out because I'm not asking for specifics here. But I am seeing if I did multiply all this out, by the time I got to multiplying all that out, wouldn't my very last term be -3 times -1 times +2? And that comes out to be a +6. And so because I counted by halves, that's not going to fit on my graph. But I could estimate that a +6, I don't know, 1, 2, 3, 4, 5, 6. Maybe +6 is going to be like up here. Okay, that's just a complete estimation. But I've zoomed in because of the halves. Okay, let's go back and remember, what is it going to look like? It's going to look something like this. Okay, this is what it's going to look like. So I want to go back and draw that in. That means from -2, it's going to come down. It's going to go through -2. It's going to come up and go through that x-intercept, come back down, and then back up through the other one. So let me show you what I mean. Okay, not the most beautiful drawing in the world. So, but this is what it's basically going to look like. It's going to be a cubic. It's going to start, the end behavior starts down here at the negative, goes up here to the positive. That's what our end behavior is going to do. It has 3 x-intercepts, and we could calculate pretty easily the y-intercept from that as well. Let's take a minute to do one more of these. Do you see how this one is squared? What does that mean? Well, a couple things. First of all, again, I'm looking at it, and once again, I do know that if I multiply this out, I'm going to get a cubic. Another thing is I know it's going to be a negative. So this time it's going to be a similar shape, but it's just going to go the other way. It's going to look like this instead because it's negative. I want to set each of these equal to 0. Okay, I set them equal to 0, and I get -2 and +1. This time I'm not going to skip so that I can fit some things in better if I need to. Plus, I don't have any fractions, so I don't really need to skip. So I'm just counting by ones. It's going to have this shape. Now notice there's only 2 intercepts where this one had 3. Where's the other intercept? Well, what's going on is if you have this second power, I call that a bounce. In other words, at the -2, remember it has this shape over here on the right. It's going to come down, it's going to bounce off of that, go back up, and then go through. Let's think about y-intercept again. If I multiply that out, that would give me a 4 times 1 is 4. Now that is a -1, but I have a negative over here. So it's going to be up at +4. 1, 2, 3, 4. So it's going to come down. It's going to hit that -2, bounce off, come back up, and then go down through here like this. And that's going to be my graph. So these factors, a lot of times people get tired of factoring. I understand that. We factor a lot in Algebra 2. But the reason we factor is so that we can graph, and we can see what the graph is doing. So that's how we graph from factors. Let's turn the page. We have a lot of different kinds of factoring. Today we're just going to talk about 2 different kinds of factoring. Factoring by grouping, and then later the GCF. Factoring by grouping is a lot like splitting the middle term. When we get into the middle of it, you'll see what I mean and how similar it is to splitting the middle term. We do factoring by grouping when you have 4 terms. Okay, if you have a 4-term polynomial, that's when you do factoring by grouping. And what you do is you take the first 2 and you put them in parentheses. And I'm going to squeeze a plus in here. We've done that before because I'm going to put this in parentheses. Now I'm going to factor out a GCF. And so that's going to be x squared. On this one, my GCF is a -25. And now look what I have. Now that can be factored, like I take out my GCF. Remember, this is, like I said, a lot like splitting the middle term. So I get, x minus 1. And I still have an x squared minus 25. Now remember, we're not done yet because this is a difference of squares. And so for the difference of squares, that means x plus 5, x minus 5. Now I'm finished. That is my final answer. That's how you do factoring by grouping. And again, it's when you have 4 terms in your polynomial. Let's go ahead and try this next one. Why don't you take a minute to set it up? do the parentheses, and then take out your GCF and see how much farther you can go. Pause the video here and see what you can do. Your answer should be x squared plus 4 times 2x plus 1. Now, if you thought you could factor out x squared plus 4, how did you think that could factor out? Did you think it would be x plus 2, x minus 2? That won't work, right? Because that would give us a negative 4. So that's not going to work. Did you think it was going to be x plus 2 times x plus 2? Well, that would give us x squared plus 2x plus 2x plus 4. That's x squared plus 4x plus 4. That's not what we have either. So actually, this does not factor any further. That is as far as you can go with that. I don't think we need to do another example. I think we've done probably enough, and we'll do some more in class. So let's skip number 3 for now. We can come back to it later if we need to in class. Okay, another method that we've learned when we were doing quadratics is if there's a GCF, let's factor that out first to make it easier. So notice there is a GCF here. What is that GCF? Well, hopefully you could see it's 20x. So let's factor out a 20x and see what we have. All right, when we factor out 20x, we get x squared minus 11x plus 30. Can that be factored? Well, yes, it can. Why don't you take a second to factor that? Okay, so the factors of 30 that add up to a negative 11 is negative 6 and negative 5. People sometimes ask, do I need to solve that? No, you don't need to solve it because there's no equals anywhere. If there was an equal sign, yes, we would have to give it equals. But here there's no equal sign, so we're not going to solve it. We're just going to factor it. Take a look at number 2. There is a GCF. It's only a variable. There's no number. It's just a variable. Factor out the GCF, and then see if you can factor it one more time. This time it's going to be by grouping. So factor out the GCF, and then factor by grouping, and see what you can do from there. Okay, let's look at this problem. Your GCF was t to the third power. You factor out your t to the third. When you factor that out, 5t to the third plus 2t squared minus 5t minus 2, you do your grouping and factor out your GCF. Once again, when you factored out your GCF, you got a t squared minus 1. And t squared minus 1 can be factored down to t plus 1, t minus 1. And so this is our final answer. So those are the first 2 kinds of factoring that we have with polynomials. We are going to learn some other methods, but those are the 2 for today. Factoring by grouping, and then GCF, and then factoring. We will, like I said, continue to work on this in class. Please write something down in the summary down here to remind yourself how to do this. Not just today we learned about factoring, but something about how you do the factoring or things you need to remember about factoring or what have you. So write some stuff down in the summary and we'll do some examples in class.